Now, in this lecture, we will find the radius of the red semicircle. In the drawing, we have triangle ABC. Triangle ABC is a right triangle. This angle equals to 90 degrees. Angle ABC equals to 90 degrees. And side AB of triangle ABC equals to 3 units. And line segment CD equals to 1 unit. And we want to find out the radius of this red semicircle. Actually, the semicircle is inscribed by this triangle. And so first of all, I will present to you a new rule. Rule number 1, or 2 tangents theorem. According to rule number 1, or 2 tangents theorem, so rule number 1 states that the lengths of 2 tangents from a common external point to a circle are equal. So I will read rule number 1 or 2 tangents theorem again. According to 2 tangents theorem, the lengths of 2 tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 or 2 tangents theorem is that if you have this circle and we have the external point, this point P. Point P is an external point of this circle because point P is not located inside this circle nor on this circle, but it is located outside this circle. Therefore, it is defined as an external point of this circle. So if from point P you will draw 2 tangents to this circle, so the first tangent to this circle will be this tangent, we define the touching point between this first tangent and the blue circle as A, and we also have a second tangent from point P to this circle, we define the touching point between the second tangent and this blue circle as point B. So according to rule number 1 of two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So actually the length of this first tangent is PA, and the length of this second tangent is PB. And according to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So the length of those two tangents PA and PB that exit from the common external point, point P to the circle are equal, that is to say PA equals to PB. So whenever you draw two tangents from a common external point of a circle to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. And we can actually implement rule number 1 of two tangent theorem in our drawing, because in our drawing we have the external point, this point A is an external point of this circle, and from the external point, point A, we have the first tangent is AB, tangent AB, and the length of tangent AB is 3 units. And we have the second tangent, tangent AE, and according to rule number 1, the length of two tangents from an external point of a circle, in this case it is point A, to the circle are equal, that is to say AB equals to AE, AB equals to AE, but we know that AB equals to 3 units, so from this equality we will conclude that AE also equals to 3 units. AE equals to 3 units, so here we can write that AE equals to 3 units, and we will define the center of the red semicircle as point O. Actually, line segment OB is the radius of this red semicircle, because of the fact that line segment OB starts from point O, that is the center of this semicircle, and ends at point B, that is a point on the semicircle itself. Therefore, OB is the radius of this red semicircle, so we will define the radius of the semicircle as R. Therefore, OB will be equal to R, the radius of the semicircle. Likewise, OD is also the radius of this semicircle, because of the fact that line segment OD starts from point O and ends, that is the center of the semicircle, and ends at point O, that is a point on the semicircle itself. Therefore, OD is the radius of this semicircle, that is to say it equals to R. In the next step, we will join together points O and E by a straight line. Actually, line segment OE is also the radius of this red semicircle, because of the fact that it starts from the center of the semicircle, that is to say from point O, and ends at point E, that is a point on the semicircle itself. Therefore, OE is the radius of this semicircle, that is to say it equals to R. So in the next step, I will present to you, but before that, as you can see from the drawing, side AC, that is actually tangent AC, is tangent to this red semicircle at this point E. So point E is the point of contact or point of tangency of tangent AC with this red semicircle. So it is point of tangency. So in the next step I will present to you a new rule, rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I will read rule number 2 again. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle, this blue circle, and the center of this blue circle is at this point, we'll define the center of the circle as point O, and this semicircle as tangent, actually tangent AB, this tangent AB is tangent to this blue semicircle at this point. We will define the touching point between tangent AB and the blue circle as point M. Actually point M is the point of tangency of tangent AB with this blue circle. And we also have radius from point O to point M. So actually line segment OM is the radius of this blue semicircle. Radius OM is the radius of this blue circle. So here, as you can see from the drawing, the radius OM is drawn to the point of tangency, that is to say to point M, that is the point of tangency. Therefore, according to rule number 2, the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees. and this angle also equals to 90 degrees. So I'll read rule number 2 again. According to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. So because of the fact that this radius is drawn to the point of tangency, that is to say to point M, that is the point of tangency, therefore the tangent AB is perpendicular to this radius. That is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, so whenever you have a radius that is drawn to the point of tangency, like in this drawing, then the tangent will be perpendicular to that radius. In this case, the tangent AB is perpendicular to this radius because this radius is drawn to the point of tangency, that is to say to point M. Therefore, the radius AB is perpendicular to this radius, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, so that is actually rule number 2. And we can actually implement rule number 2 in our drawing, because in our drawing we have the radius OE that is drawn to the point of tangency, that is to say to point E, that is the point of tangency. Therefore, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle also will be equal to 90 degrees. So actually, because of the fact that this angle OEC, is a right angle, it equals to 90 degrees, therefore triangle OEC is a right triangle. Okay? This green triangle OEC, is a right triangle because it has one angle that equals to 90 degrees. So we will focus on the green right triangle OEC. So in the right triangle OEC, this right green triangle OEC, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the hypotenuse of the green triangle is side OC because it is located in front of the right angle, in front of angle OEC, that is a right angle. Therefore OC is the hypotenuse of this green right triangle. So the square of the hypotenuse is OC squared, and it equals to the sum of the squares of the perpendiculars. It equals to OE squared plus EC squared. We will define side EC, the side EC as x, that is to say EC equals to x units in its size. So in total we got that in the right triangle, right green triangle OEC, according to the Pythagoras theorem, OC square equals to OE square plus EC square. But what is the value of OC? The value of OC, as you can see from the drawing, OC equals to R plus 1. Therefore, OC square will be equal to R plus 1 square. and it equals to OE square. OE equals to R, so OE square will be equal to R square plus EC square. EC equals to X, so EC square will be equal to X square. So in total, we got that R plus 1 square equals to R square plus X square. We will open the brackets of R plus 1 square, and we will get that R plus 1 square equals to R square plus 1 plus 2R according to the algebraic identity that A plus B square equals to A square plus B square plus 2 times AB. And it equals to R square plus X square. Here we'll subtract R square from this equation number 1. So R square will get cancelled. And what is left from equation number 1 after we cancelled R square? What is left actually is two R plus 1 equals to X squared. Okay, according to equation number 1, 2R plus 1 equals to X squared. So in the next step we will focus on the right triangle, triangle ABC, and also on the green small right triangle, triangle EOC. And we will prove that those two triangles are similar to each other. Okay? So we will focus on triangle ABC and triangle OEC. First of all, those two angles, they are equal to each other and they are both equal to 90 degrees. They are right angles, so we can write down the angle ABC, this angle in triangle ABC is equal to angle EOC, this angle, and both those angles are equal to 90 degrees. They are right angles, so actually angle ABC equals to angle EOC, and they are both equal to 90 degrees. They are right angles. In addition to that, also this angle is a common angle. It belongs both to the big triangle, triangle ABC, and angle C. This angle also belongs to the green triangle. So we can write down that angle C equals to angle C. It's a common angle that belongs to both triangles. I will repeat again. Angle C equals to angle C is a common angle that belongs to both triangles. And also those two angles are equal to each other according to third angle theorem. So angle BAC, this angle in triangle ABC, is equal to angle EOC in triangle EOC according to third angle theorem. repeat again. Angle BAC equals to angle EOC according to third angle theorem. So what is third angle theorem? Third angle theorem is rule number 3 or third angle theorem. It is the same. So, according to third angle theorem, or third angle theorem states that if two angles of one triangle congruent to two angles of another triangle, then the first pair of angles must also congruent. So I will read rule number 3 of third angle theorem again. According to third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of third angle theorem? The meaning of third angle theorem is that if you have two triangles triangle ABC so this is triangle ABC, and we also have another triangle, triangle BEF. This is triangle DEF. And in those two triangles we have two pairs of angles that congruent. The first pair of angles that congruent are those angles. So actually those two angles are congruent to each other. They are both equal to alpha, and we have the second pair of angles that also congruent to each other. So those are the second pairs, the second pair of angles that can go into each other. They are both equal to beta. And if this angle is gamma and this angle equals to theta, so if this is the situation that we have two triangles with two pairs of angles that can go into each other, then according to third angle theorem, the third pair of angles must also can go into each other. That is to say, angle gamma equals to angle theta. According to third angle theorem, angle gamma equals to angle theta. I'll repeat again. If we have two triangles with two pairs of angles that can go into each other, like in this drawing, then the third pair of angles must also can go into each other. That is to say, angle gamma equals to angle theta. So we will prove that indeed angle gamma equals to angle theta, and we will prove it by using the rule that the sum of the angles in any triangle equals to 180 degrees. Okay, so in triangle ABC, according to that rule, the sum of its angles equals to 180 degrees. That is to say, this triangle, alpha plus beta plus gamma equals to 180 degrees according to the rule that is stated. I will repeat again. In triangle ABC, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles are also equals to 180 degrees. That is to say, in triangle DEF, so in triangle DEF, alpha plus beta plus theta equals to 180 degrees. According to the rule that is stated, the sum of the angles in any triangle equals to 180 degrees. So therefore, in triangle DEF, alpha plus beta plus theta equals to 180 degrees. Okay. So here we will subtract equation number 1 from equation number 2. So alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees. Minus 180 degrees, it's 0. So we found out that according to equation number 3, gamma minus theta equals to 0, and in this way we actually proved the rule number 3, because we proved that angle gamma equals to angle theta. Angle gamma equals to angle theta. That is exactly what we wanted to prove. So we actually proved that if we have two triangles with two pairs of angles that are equal to each other, then the third pair of angles must also equal to each other or congruent. So if we have two pairs of angles that congruent, like in this drawing, then the third pair of angles must also congruent. That is to say, angle gamma equals to angle theta, and we actually proved that angle gamma equals to angle theta. Here we actually add theta to this equation number 3, and we will get that angle gamma equals to angle theta. Okay, we actually proved that angle gamma equals to angle theta. Exactly what we wanted to prove, that angle gamma equals to angle theta. That is to say, if we have two triangles with two pairs of angles that congruent, then the first pair of angles must also congruent. That is to say, angle gamma equals to angle theta. Okay? So, we will return to our original drawing, and we actually proved that all three angles of the big triangle, triangle ABC, congruent to all three angles of the green triangle, triangle OEC. Therefore, we actually proved that triangle ABC is similar to triangle OEC, the green triangle, according to angle similarity rule. I will repeat again. We actually proved that triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles of one triangle congruent to all three angles of the other triangle, then those two triangles can similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to the green triangle, triangle OEC, we will conclude that AB over AC in triangle ABC, AB over AC in triangle ABC equals to OE over OC in the green triangle, triangle OEC. I will repeat again, from the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC in triangle ABC is equal to OE over OC in the green triangle, triangle OEC. Okay? And what is the value of OC? The value of side OC of the green triangle is actually equal to R plus 1. And what is the value of AC? AC equals to 3 plus X. So we found out here AB okay. Actually AB equals to 3 units. It is given us in the question that AB equals to 3 units. So AB equals to 3. And AC equals to 3 plus X. AB equals to 3 units and AC equals to 3 plus X. I will repeat again. AB equals to 3 units and AC equals to 3 plus X. And what is the value of OE? The value of OE is equals to R. It is the radius of this red semicircle. And what is the value of OC? OC equals to R plus 1, as you can see from the drawing. So we found out that AB equals to OE equals to R and OC equals to R plus 1. So in total we got that 3 over 3 plus X equals to R over R plus 1. Here we will cross multiply equation number 2 and we will get that 3 times R plus 1 equals to R times 3 plus X. Okay, after we cross multiply equation number 2, we got this expression. Here we open the brackets in equation number 2 and we will get that 3R plus 3 equals to 3R plus R times X. Here we will subtract 3R from equation number 2, this equation. So 3R will get cancelled, and what is left after we cancel 3R from equation number 2? What is left is actually that 3 equals to Rx. Here we divide equation number 2, this equation, by x. It is allowable to divide equation number 2 by x because x can never be 0. X is the side of the one side of the green triangle. It must be a positive number. It can never be 0. Therefore, it is allowable to divide equation number 2, this equation, by x. Okay, and we will get that the radius of the semicircle equals to 3 over x. So we found out that the radius of the semicircle R equals to 3 over x, but according to equation number 1, 1 plus 2R equals to x squared. Therefore, we found out that according to equation number 1, 1 plus 2R equals to x squared. So here we can substitute R in this equation number 1, by 3 over x, because R equals to 3 over x according to equation number 2. So we'll do it now and we will get that 1 plus 2, and instead of R we write down 3 over x, that equals to R equals to x squared. After we substituted R by 3 over x, we got this expression. So here 2 times 3 is 6, so we write it down. One plus 6 over x equals to x squared. So here we will multiply equation number 1, this equation by x, and we will get that x times 1 is x, 6 over x times x, 6 over x times x is 6, and x squared times x is x cubed. So here we will subtract x from equation number 1 and we will get that x cubed minus x equals to 6. Here we will subtract 6 from this equation number 1 and we will get that x cubed minus x minus 6 equals to 0. So here we will add, actually, as you already know, minus 2x squared or plus 2x squared is 0. So we can add 0 to any equation, therefore we will add this expression that equals to 0 to this equation number 1 and we will get that x cubed minus 2x squared plus 2x squared, that is 0, minus x minus 6 equals to 0. Okay, so here we will substitute minus x. We know that minus x equals to minus 4x plus 3x. I'll repeat again, minus x equals to minus 4x plus 3x. So we can substitute minus x in this equation number 1 by minus 4x plus 3x. Okay, so we will do it now and we will get that x cubed minus 2x squared plus 2x squared, and instead of minus x we will write down minus 4x plus 3x. So actually, after we substituted minus x by minus 4x plus 3x, we got this equation number 1. So here we will divide this equation number 1 to 3 parts and we will take a common factor from each part. This will be part number 1, this will be part number 2, and this will be part number 3. Okay, so we will take a common factor from the first part. The first part number 1 is x cubed minus 2x squared, and the common factor that we will take from this expression is x squared. So what is left from x cubed after we took from it x squared? What is left? It is actually x. And what is left from minus 2x squared after we took x squared as a common factor? What is left? It is actually minus 2. So in total we found out that x cubed minus 2x squared equals to x squared times x minus 2. We will repeat on the same process on the second part of the expression. The second part of equation number 1 is 2x squared minus 4x. Here we will take the common factor of 2x from this expression. So what is left from 2x squared after we took 2x as a common factor? What is left, it is actually x. And what is left from minus 4x after we took 2x as a common factor? What is left, it is actually minus 2. Again, we will repeat on the same process on the third expression. On the third part, this is the third expression. So third expression is 3x minus 6, and the common factor that we will take from this equation is 3. So what is left from 3x after we took from it 3 as a common factor? What is left, it is actually x. And what is left from minus 6 after we took 3 as a common factor? What is left, it is actually minus 2. So in total we got that 3x minus 6 equals to 3 times x minus 2. So here we have 3 expressions and their 3 identities. So we will substitute the 3 expressions by their 3 identities, and we know that the sum of the 3 expressions equals to 0. So the sum of those 3 expressions that are actually x, instead of x cubed minus 2x squared, we write down x squared times x minus 2. And repeat again, instead of x cubed minus 2x squared, we will write down its identity, x cubed, x squared times x minus 2. And instead of 2x squared minus 4x, we will write down 2x times x minus 2. And instead of 3x minus 6, we will write down 3 times x minus 2 that equals to it. And we know that all equals to 0. Okay. So we get actually this expression after we substituted the 3 original expressions by their identities. We got this expression. So here we will take a common factor of x minus 2 of this equation number 1, and we will get that x minus 2. So x minus 2 is a common factor of equation number 1. So what is left from this expression after we took x minus 2 as a common factor? What is left is actually x squared. And what is left from this expression after we took x minus 2 as a common factor? What is left? It is actually 2x. And what is left from this expression after we took x minus 2 as a common factor? What is left? It is actually 3. And it equals to 0. So here we have 2 solutions that are possible for equation number 1. Either x minus 2 will be equal to 0, or it's possible also that the quadratic equation x squared plus 2x plus 3 will be equal to 0. Okay, so we have here a quadratic equation, x squared plus 2x plus 3 is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here in this general formula for a quadratic equation, a, b, and c are the coefficients of this general quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula for x. Actually, x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay? So we will use this formula in order to find out the value of x that we are looking for. And in our specific quadratic equation, x squared plus 2x plus 3 equals to 0, the coefficients of this specific quadratic equation are as follows: a equals to 1, b equals to 2, and c equals to 3. So we will put the data inside this formula for x in order to find out the value of x in our specific quadratic equation. Okay? So we will get that x equals to minus b, b equals to 2. If b equals to 2, minus b is minus 2, plus minus square root of b squared. B equals to 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a is 1, c is 3. So minus 4 times ac is minus 4 times 1 times 3 over 2a. 2 times a is 1, so 2 times 1 is 2. So in total we will get that x equals to minus 2 plus minus square root of 4 minus 4 times 1 times 3, minus 4 times 1 times 3 is minus 12, all divided by 2. So x equals to minus 2 plus minus square root of 4 minus 12 is minus 8 over 2. So minus 8 is a negative number, and we don't have, there is no root for a negative number. A negative number doesn't have a root. Therefore, we are stuck here. It means that the quadratic equation x squared plus 2x plus 3 doesn't have a solution. Therefore, we will abandon this option. This option is not correct option because we are stuck here. And the only solution that is possible is the first solution, that x minus 2 equals to 0. Okay, so if x minus 2 equals to 0, then x will be equal to 2. X equals to 2. And we have already found out that according to equation number 2, the radius of the red semicircle equals to 3 over x. So here we can put the value of x inside this equation number 2, and we will get that the radius of the red semicircle equals to 3 over x is 2, 3 over 2 units. Or we can represent it also that the radius of the semicircle equals to 1.5 units. Okay, I will repeat again. The radius of the red semicircle equals to either 3 over 2 units, or it also equals to 1.5 units. I will repeat again. The radius of this red semicircle equals to either 3 over 2 units, or r equals to 1.5 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this right semicircle. We know we have a triangle ABC is a right triangle. Angle ABC equals to 90 degrees. Side AB of triangle ABC equals to 3 units. Line segment DC equals to 1 unit. And we want to find out the radius of this right semicircle. So first of all, I presented to you rule number 1, that is the two tangents theorem. According to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1 of two tangents theorem? Actually, two tangents theorem means is that if you have an external point, point P of this circle, and from the external point P you will draw two tangents to this circle, then the length of those two tangents will be equal to each other. That is to say, PA equals to PB. So I'll repeat again. The length of two tangents from a common external point to a circle are equal. So if we have this external point, point P, and from this external point we will draw two tangents to this circle, so then the length of those two tangents will be equal to each other. That is to say, the length of the first tangent is PA, the length of the second tangent is PB. According to rule number 1, those lengths are equal to each other. That is to say, PA equals to PB. So whenever you draw from a common external point two tangents to a circle, like in this drawing, then the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. And we can actually implement rule number 2 in our drawing, two tangents theorem in our drawing, because here we have the external point, point A, and from the external point A we have two tangents to this right semicircle. The first tangent is AB, the length of the AB is 3 units, and the second tangent is tangent AE. And according to two tangent theorem, whenever you draw two tangents to a circle from an external point to that circle, then the length of those two tangents will be equal to each other. That is to say, AB equals to AE. AB equals to AE according to rule number 1, but we know that AB equals to 3 units. It is given us in the question that AB equals to 3 units. Therefore, from this equality, we will get that AE also equals to 3 units. So line segment AE equals to 3 units. Okay, then I presented to you rule number 2. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and we have the tangent AB is tangent to this blue circle at point M. Point M is the point of tangency of tangent AB with this blue circle. So then we will draw the radius OM. As you can see from the drawing, the radius OM is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency. Therefore, according to rule number 2, the tangent AB will be perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. I will repeat on rule number 2 again. A tangent to a circle, that is to say, tangent AB, is perpendicular to the radius drawn to its point of tangency. So this radius, the radius OM, is drawn to the point of tangency. Therefore, the tangent AB is perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And we can actually also implement rule number 2 in our drawing, because in our drawing we have the tangent AC that is tangent to this red semicircle at point E. Point E is the point of tangency. And we have this radius, the radius OE, this radius, the radius OE is drawn to the point of tangency. That is to say, to point E, that is the point of tangency. Therefore, the tangent AC is perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. And because of the fact that this angle OEC equals to 90 degrees, then the green triangle OEC is a right triangle. So we will focus on the green right triangle OEC according to the Pythagoras theorem. In the green right triangle OEC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OE square plus EC square. OC equals to R plus 1. Side OC equals to R plus 1. OE equals to R and EC equals to X. So in total we will get that OC square equals to R plus 1 square, OE square equals to R square, and EC square equals to X square, or R plus 1 square equals to R square plus X square. We open the bracket on this side of equation number 1 and we got that R plus 1 square equals to R square plus 2R plus 1, and it equals to R square plus X square. Here we subtracted R square from equation number 1, this equation number 1, and we got that 2R plus 1 equals to X square according to equation number 1. Then we focused on the right triangle ABC, on the green small right triangle OEC, and we proved that those two triangles are similar to each other. First of all, we know that angle ABC, angle ABC is equal to angle OEC. They are both right angles, therefore they are equal to each other. Angle ABC equals to angle EOC equals to 90 degrees. We also know that this angle C is a common angle. It belongs both to the big right triangle ABC. It belongs also to the small right triangle, green triangle OEC. So we can write down that angle C equals to angle C. It's a common angle that belongs to both triangles. And we also know that those two angles are equal to each other according to third angle theorem. So actually, angle BAC equals to angle EOC according to third angle theorem. So what is the third angle theorem? Third angle theorem, or rule number 3, states that if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of third angle theorem, or rule number 3? The meaning of third angle theorem is that if you have two triangles, we have triangle ABC and triangle DEF, and in those two triangles we have two angles, two pairs of angles that can go into each other. Those are the first pair of angles that can go into each other. They are both equal to alpha. And those are the second pair of angles that can go into each other. They are both equal to beta. So if this is the situation, that we have two pairs of angles that can go into each other, then the third pair of angles must also congruent. That is to say, angle gamma also must be equal to angle theta. And I proved that the third angle theorem is true. That is to say, I proved that rule number 3 is true. This rule is true by using the rule that states that the sum of the angles in any triangle equals to 180 degrees, and especially the sum of the angles of triangle ABC equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. In triangle DEF, alpha plus beta plus theta equals to 180 degrees. Here we subtracted equation number 1 from equation number 2, and we got that alpha minus alpha equals to 0, beta minus beta equals to 0, and gamma minus theta equals to 180 degrees minus 180 degrees equals to 0. That is to say, gamma minus theta equals to 0. According to equation number 3, we added theta to equation number 3, and we got that angle gamma equals to angle theta. And this is exactly what we wanted to prove, that if we have two triangles with two pairs of angles that can go in, then the first pair of angles also can go in. That is to say, we wanted to prove that angle gamma equals to angle theta, and we indeed proved that angle gamma equals to angle theta. Okay? So we actually proved that the third angle theorem is true. And we return to our original drawing. In our original drawing, we actually proved that all three angles of the right triangle, triangle ABC, can go into all three angles of the right green small triangle, triangle EOC. Therefore, we proved the triangle ABC is similar to triangle OEC, the green triangle, according to angle similarity rule. Okay? We proved the triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles of one triangle can go into all three angles of the other triangle, then you actually prove that those two triangles similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to triangle OEC, we will derive or we will conclude that AB over AC in triangle ABC equals to OE over OC in triangle OEC. But we know that AB equals to 3 units. It is given us in the question. AC equals to 3 over X. And OE equals to R, and OC equals to R plus 1. So in total we will get that AB over C equals to OE over OC. It means that 3 over 3 plus X equals to R over R plus 1. Okay, here we cross multiply the equation number 2, and we got that 3 times R plus 1 equals to R times 3 plus X. Here we open the brackets of this equation number 2, and we got that 3R plus 3 equals to 3R plus R times X. We subtracted 2 from this equation number 2, and we got the equality that 3 equals to R times X. We divided this equation by X. It is allowable to divide the equation by X because X is a side of a triangle. It can never be 0. Therefore, it is allowable to divide this equation by X. So we divided this equation number 2 by X, and we got that the radius of the semicircle equals to 3 over X. Okay? But this is according to equation number 2, but according to equation number 1, we have already found that 1 plus 2R equals to X squared. So here we can substitute 2R by 3 we can substitute 2R in equation number 1 by 3 over X, because 3 over X equals to R according to equation number 2. So we substituted 2R by 3 over X, and we got this equation number 1 that states that 1 plus 2 times, and we substitute R by 3 over X equals to X squared. Here 2 times 3 is 6, so we got that 1 plus 6 over X equals to X squared. We multiplied this equation number 1 by X, and we got that X plus 6 equals to X cubed. we subtracted x from this equation number 1 and we got that x cubed minus x equals to 6. We subtracted 6 from this equation number 1, and we got equation number 1 that states that x cubed minus x minus 6 equals to 0. Here we added the expression minus 2x squared plus 2x squared to equation number 1. Minus 2x squared plus 2x squared equals to 0, so, and it is allowable to add to any equation 0. Therefore, it is allowable to add this equation that equals to 0 to equation number 1. After we added this expression to equation number 1, we got this expression, and then we substituted minus x in this equation number 1 by minus 4x plus 3x. Minus 4x plus 3x equals to minus x. So therefore it is allowable to substitute minus x by minus 4x plus 3x. And after we substituted minus x by minus 4x plus 3x, we got that this equation number 1, we divided equation number 1 to 3 parts, and we took a common factor from each part. So part number 1 is x cubed minus 2x squared, and the common factor that we took from this expression is x squared, and what is left inside the bracket after we took x squared as a common factor is x minus 2. Then we took a common factor from 2x squared minus 4x. We took a common factor from 2x squared minus 4x, and the common factor that we took from this expression is 2x, and what is left inside the brackets after we took 2x as a common factor is x minus 2. Then we took a common factor from the third expression from 3x minus 6, from 3x minus 6, and the common factor that we took from this expression is 3, and what is left inside the bracket is 3 times x minus 2. Then we substituted those three expressions by their identities, and we got this expression, equation number 1. Here we took a common factor of x minus 2. We took a common factor of x minus 2 from this equation number 1. So here x minus 2 is a common factor of this equation number 1. And what is left from this expression after we took x minus 2 as a common factor? What is left? It is actually x squared. What is left from this expression after we took x minus 2 as a common factor? What is left? It is actually 2x. And what is left from this expression 3 times x minus 2 after we took x minus 2 as a common factor? What is left? It is actually 3. So in total we got this equation number 1. Here we have two solutions that are possible to this equation number 1. The first solution that is possible is either x minus 2 equals to 0, or the other possibility is that the quadratic equation x squared plus 2x plus 3 equals to 0. We focused on the second solution, and we tried to solve this quadratic equation in order to find out the value of x. The general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x by using this special formula for x. And x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So we will use this formula in order to find out the value of x. So in our specific quadratic equation, x squared plus 2x plus 3 equals to 0, the coefficients are as follows: a equals to 1, b equals to 2, and c equals to 3. So we will put the data inside this formula in order to find out the value of x. So we put the data inside this equation and we found out that x equals to minus b equals to 2, so minus b is minus 2, plus minus square root of b squared. B is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a times c, minus 4 times a is 1, c is 3, so in total minus 4 times a times c is minus 4 times 1 times 3, divided by 2a, a is 1, so 2 times 1 is 2. So we got that x equals to minus 2 plus minus, and here 4 times 1 times 3 is 12. So in total we got that x equals to minus 2 plus minus square root of 4 minus 12, because 4 times 1 times 3 is 12. So all divided by 2. And 4 minus 12 is minus 8. So we got this expression that x equals to minus 2 plus minus square root of minus 8 over 2. But because of the fact that minus 8 is a negative number and a negative number doesn't have a root, so we stuck here. Therefore this quadratic equation doesn't have a solution because we are stuck here. It means that we will abandon this possibility, and the only possibility that is left, that the solution to our equation number 1, the only solution is that x minus 2 equals to 0. And if x minus 2 equals to 0, then x equals to 2. And we have already found out, according to equation number 2, that the radius of the semicircle equals to 3 over x. R equals to 3 over x. So we can put x inside this equation number 2. We know that x equals to 2, so we will put 2 inside this equation number 2, and we found out that the radius of the semicircle equals to r equals to 3 over x, and x is 2, so r equals to 3 over 2 units, or we can represent it that r equals to 1.5 units. So I'll repeat again, the radius of this red semicircle r equals to either 3 over 2 units, or we can represent it also as 1.5 units. Again, the radius of this red semicircle equals to either 3 over 2 units, or it can also be represented by 1.5 units. Okay, thank you very much.